we're going to spend a couple days in section 1-3. And for today, I just want you to be able to simplify, multiply, and divide square roots. We'll go over some vocabulary words. I just want to make sure everyone understands what a radical symbol is. Now, you might just call this a square root, and it is a square root, but as we go through the year, we're going to introduce some radicals that might have an index, say, of 3 for a cubed root. So this is called a radical symbol, and if there's nothing there, it is a square root. The next vocabulary I want you to know is radicand, and a radicand is the number or variables underneath the radical symbol. So if I would do this, 4 would be the radicand. The principal roots are the positive square roots of a number. And rationalizing the denominator, that has to do with square roots. It's the process of removing the radical from the denominator, and we'll talk about that more tomorrow. Now, like radical terms, with respect to square roots, are radicals that have the same radicand. Now, later in the year, we'll do other roots besides square roots. So if you have, think back to geometry, if you have a square that has an area of 25 feet squared and you wanted to find the length of one squared, you would take, one side, you would take the square root of this, and that would be 5 feet. So that's what basically you're doing when you take the square root of something. Okay, now, we want to look at the first 10 perfect squares. So it's good if you can be able to identify those. And we can just start out basically by counting. Now, I just want to mention that square roots of integers that are not perfect squares are going to be irrational numbers. So let's just start listing some perfect squares. We can start with 1. And then if we go to 2, the perfect square would be 4. 3, perfect square, 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. Let me just move this up. 9 squared is 81. And 10 squared is 100. Now, if we take the square root, it's always important to remember that when you take the square root, you have a positive and negative value. So these are a plus or minus 1, plus or minus 2, plus or minus 3, and so on. When we talk about the principal root, we're talking about the positive value when we take the square root. So the principal root for, if we would take the square root of 1, it would be 1, and then again, it's just the positive value that you get when you take the square root. All right, we want to look at a couple properties of square roots. The first one is the product property. Now, product means to multiply. So when we do the product property, we have square roots, and we can take them apart, we can put them together. So if we want to write that out algebraically, we can say that if we have the square root of a times b, it's the same as saying the square root of a times the square root of b. And that goes back and forth. You can also start with this side and go back to here. So what does that mean if we put some numbers in there? Well, we can use the square root of 8 times the square root of 2. Now, neither one of these are perfect squares, but if we multiply them together, you get a perfect square. So the square root of 8 times the square root of 2, since these are both square roots, we can put the radicands, we can multiply those together and put them under one square root. So the square root of 8 times the square root of 2 is just going to give us the square root of 16, and that simplifies. If we just want the principal root, it's going to simplify to 4. Now, if we don't say the principal root, we would put plus or minus 4 there. Okay, so that's the product property. Then we're going to do the quotient property. Now, the quotient means to divide. So algebraically, if we can say the square root of a divided by b is the same as the square root of a over the square root of b. So just like here, we can split up the square roots. Now sometimes it's better to split them up, sometimes it's better to put them together. So let's look what that means with numbers. We have the square root of 36 over 25. If we would divide that, it would make it a more difficult problem. However, if you recognize, and it's always a plus if you can recognize perfect squares, we can take these apart and say the square root of 36 over the square root of 25, which is going to just give you the square root of 36, we're doing the principal root, is 6. The square root of 25 is 5. Okay, so you're doing product and you're doing quotient. All right, when you simplify a square root, you need to make sure that the radicand, so the number underneath the radical sign, has no perfect squares. And no perfect square factors except for 1. You also need to make sure that there are no radicals in the denominator. We'll deal with that tomorrow. And you need to rationalize the denominator, something else that we'll do tomorrow. Okay, so let's simplify these expressions. Now, there's a couple of different ways you can do this. You can look for perfect squares, and if you recognize your perfect squares, you can say, okay, what two numbers multiplied together, and one of them is a perfect square, will give me 24. Well, the square root of 4 and the square root of 6 will give you 24. So we're using that product property, and we're breaking this up. Now we can change the square root of 4 to 2. So this would be 2 times the square root of 6. Now, if you don't want to do that, there's another way you can simplify the expressions, and you can use a factor tree. Now, a factor tree, we would just going to write this on another sheet of paper here. We can use a factor tree, and because the 24 is even, I'm going to use 2. You can break it up however you want. It doesn't really matter, just as long as you're choosing two numbers that divide 24. So I'm going to use 2 and 12, and then I'm going to circle this because it's prime. Any prime number I'm going to circle. If it's not prime, I need to break it up. So this is 2 and 6. There's a prime. And 2 and 3. There's a prime. Now, if I did this correctly, I should be able to multiply 2 times 2 times 2, which is going to give me 8, and then multiply it by 3, which is going to give me 24. Okay, now what I'm going to do is I'm going to take all of those numbers, I'm going to put them under a square root sign. Let me just do that off to the side here. That would give me the square root of 2 times 2 times 2 times 3. Okay, and again, that all equals 24. Now, because this is a square root, we have to circle these in pairs. So if you circle it in as pair, it's going to come out as just a 2, because what you're basically asking when you're taking the square root of something, what number do I multiply by itself to get the value? So we're multiplying 2 by itself. So kind of think about that as a square root of 4. Well, what's the square root of 4? You know that that is just 2. And if you just want to see if I'm off the screen here. If you do factor that out, it's 2 times 2. So we would circle these two, and we would bring them out because they're a pair, and that would just be 2. Okay, so for that reason, we're going to circle this as a pair. That comes out as a 2. Now, whatever's on the outside stays on the outside. The 2 and the 3, they don't have a pair, so they have to stay underneath, and we're just going to multiply those together. So that's going to equal, we'll write what's on the outside, which is 2, times the square root of 6, which is the same answer that you get here. So if you can recognize the perfect squares, it's really faster, but it's not necessary. You can do it either way. So I'm going to do it both ways here. If I do, I know that 9 times 8 is 72. So I have 9 times 8 is 72. I also know that there's a perfect square in 8. So I could say the square root of 9 times the square root of 4 times the square root of 2. Okay, now if I take the square root of each one of those individually, it would be 3 times 2, and then this would just be the square root of 2. So that's going to give me 6 times, and we don't need that actually, so 6 times the square root of 2. All right, now if I wanted to do a factor tree, going to do that just beside here. I would do 72, and then I would do 9 times 8, or you could do 2 times 36, and then we would do 3 times 3. Those are both prime. And 8 is 2 times 4. There's a prime. And 2 times 2. Okay, now we would put all those primes underneath a square root sign. So it would be 2 times 2 times 2 times 3 times 3. And remember that in order to bring the number out, you have to circle it as a pair. This would actually be the square root of 4. We know that that is 2. So I can bring that out. And I have 3 times 3, so I can bring that outside. So I have 2 times 3 on the outside, which is going to be 6. Once you take them out, just cross them off, and you're going to get 6 times the square root of 2, which is the same thing I have here. All right, last two examples we're going to change because they were the same as what they were up above in the notes. So here, if you notice, those are perfect squares. We can break them up and say the square root of 81 over the square root of 4, which is going to be 9 over 2. And here we have, we could break that up. It would be a little bit more work to do that, and then they would reduce. But the easiest way to do this one is to say, okay, if they're not perfect squares, we're going to try to divide them. 24 divided by 6 is going to give me 4. And then that answer is just, oops, that's not going to be 4. It's the square root of 4. So that's going to give you 2. So when you're simplifying square roots, just remember those properties. The quotient property, you can split them up or put them together. So it goes back and forth. And the product property, same thing. You can split them up or put them together, just depending on what type of question you have.